Hi, and welcome to this video on making inferences from a random sample. We'll be using proportions with random sampling. Okay, it would be good if you had this worksheet so that you could follow along. We're actually going to skip the first question and begin with 10.2. So I zoomed in and let's read 10.2, making inferences from a random sample. A university has 30,300 students, 330 students. In a random sample of 270 students, 18 speak 3 or more languages. Predict the number of students in the university that speak 3 or more languages. So in this problem, they're talking about random sampling and they're talking about a population and a sample, but really this is just a proportions problem. So when I look at the sample they conducted, I can just write the results of that sample as a ratio of the 18 that speak 3 or more languages over the 270 total. And then I'm going to create a proportion. And the question is how many students speak 3 or more languages. So that's my unknown. And I put that next to the 18. And then the total number of students I'm looking at is 30,330. So now I'm just going to find a scale factor. 270 times what is 30,330, and then multiply that scale factor by 18 to solve my proportion. And when I do that, I get the answer is 2,022. So the prediction would be about 2,000 students on campus speak 3 or more languages based on the random survey. Let's look at 10.3. A store receives a shipment of 5,000 MP3 players. In a previous shipment of 5,000 MP3 players, 300 were defective. A store clerk generates random numbers to simulate a random sample of this shipment. The clerk lets the numbers 1 through 300 represent defective MP3 players, and the numbers 301 through 5,000 represent working MP3 players. And the results are given. And then they have 10 numbers down here, and these are the random number generator spit out these 10 numbers. So based on this sample, how many of MP3 players might the clerk predict would be defective? So what I'm going to do is I'm going to look for any numbers that are from 1 to 300, because those are the numbers that represent a defective MP3 player. So 13 is between 1 and 300, but 2,195 is not. This one's not. This one, 525 is bigger than 300, bigger than 300. This number here is between 1 and 300, so that's going to count. So I'm going to cross out the ones that are not. That are these would represent, all the numbers that are crossed out in green would represent working MP3 players, whereas the 2 in yellow represent numbers that are between 1 and 300. So, based on that, I'm going to use this sample and say that 2 out of the 10 we can predict would be defective, which means they are not working. If that's the case, then I would say 2 out of 10 total would not work, which would mean that I would have the total number down here as 5,000 in the shipment, and I could use that to make a proportion to predict the number that would be defective. And using a scale factor, I would find that 1,000 are possibly defective. Now, 2 out of 10, 10 is not a very good number for a sample, so it seems like we have a very high number of defective, and I don't know if that would be accurate or not. So to say, is the prediction valid? Well, I just don't know if 10 is a good total for your sample. You probably should have, maybe you should have run this like 30 times. That would have been a better predictor. But they're hoping that there's less than 1,000 defective, but that's their prediction based on their sample. That being said, do you think we can answer now the essential question? How would you answer? How can you use random samples to solve real-world problems? How could you answer that question? My answer is that I would use proportions. I would make a ratio from the sample that was given. So they'll give you a sample, so many out of what the total sample was. That would be a ratio. And then the other ratio would be the unknown prediction on the numerator, and the denominator would be the total population. So I hope this was helpful in making inferences from a random sample, and thanks for watching.